Welcome to today's session titled Best Practices for Mapping Your Revit MEP Route. My name is Kirk Pesta, and I'll be your presenter today. I work for a firm called Harley Ellis Devereaux, which is a full-service architectural and engineering firm headquartered in Southeast Michigan, with offices across the U.S. There's two other people in the audience who are with my firm. I'm going to briefly introduce them. Brett Gotti, who is our corporate CAD BIM manager. Sean Rahacek was a senior project architect and associate with our firm. They're not part of the presentation, but they're going to be available as added value to this presentation for the Q&A afterwards, because we're going to be talking about our experience on implementing BIM at an AE firm and the benefits that we've received from that. About 2.5 to 3 years ago, we decided that we would get into the BIM realm. We had been 3D for a while, but not BIM. So we assembled a team together to examine what options we had out there, and ultimately we settled on Revit. So today's presentation, the basic thing I want to do is give back on what our experience has been, and you'll be the benefit of that, of our experience of the last 2.5 years. I'm having a good time in AU. This has been probably the most informative AU for me, from a mechanical sense. I've been to a lot of the Revit MEP sessions, and I've been soaking up the information, and it really looks like there's a lot more users now with Revit MEP. I can't say that I've bumped into a lot of people who are using Revit MEP smoothly for all systems, mechanical, electrical, plumbing, and piping, but the pool is growing on the experience. The class is intended to be about 90 minutes, but I've got about 70 minutes of presentation. I recognize today is the last full day of the last session of the day, and there's an event afterwards, so I'm going to leave plenty of time for Q&A. We'll stick around as long as it takes. Brett and Sean will help me field any questions that are outside of mechanical realm. As a mechanical engineer, I thought when I was going through what am I going to speak about, I wanted to frame it in a way that I can give back to you guys. What would a mechanical engineer look for if they were going to implement BIM, or if they were just into BIM for a short period of time? So this session is really geared toward the early Revit user, and there's some nuggets for the more advanced Revit user. Revit in itself, the MEP, is still kind of on a learning curve, maybe to say that lightly for some of us. And I wanted to make sure that the early Revit user who's just jumping into it can see how we did it, and where we're at today, and what we actually benefited out of it. And then afterwards, you can ask all kind of questions about where we're at, today and where we're going with it. That's fine. So in the more advanced user, I think you'll be able to kind of benchmark where you're at regarding another mechanical or AE firm as we are. So there should be something here for everybody. Quickly a poll of the room. How many mechanical, electrical technicians or designers who are directly involved in the project delivery are in this room? Great, real high percentage. What about people who are more of an engineering management role? Okay, great, good. Any architects in the room? Oh, a few of you. I know you're an architect. Okay. We're going to talk about your strategy and expectations. They go hand in hand. When you're looking at Revit MEP, how you want to use it, you have to set a strategy, but first you have to kind of figure out what is my expectation. So we're going to really talk about that first. Then we're going to talk about what are some of the best practices that my firm has found going through for early setup. And that's going to roll right into how we work with architects. We're all part of a project team. And just as engineers, we're always planning, right? We're always looking at things. A lot of times it's black and white. We want to go through steps 1 through 10 or whatever it is. Well, you need to do the same thing about how you roll out your BIM. And even if you've been in it a while, you need to evaluate that and see if it's still appropriate, the plan you've got in place. We'll take a break there just for a few minutes for questions. Then we'll get more into best practices regarding families and what we've done as our firm. And then we'll talk about benefits that we've seen. I've got some screen captures here, and wrap it up with some helpful tips. The handout that you have is very similar to what my presentation will be in terms of the content that's in there. It's not word for word or anything like that. Don't worry. But there are a few deviations. So if you think I skipped something, it's just because I condensed down my presentation a little bit. So we're talking about Revit expectation strategy. It really should be Just, it should be your expectations first, then your strategy, not as the slide is titled. Let's talk about BIM. You've been hearing all week. If you're in this class, you know about BIM, and it probably means something different to everybody in here. You may have a common theme, information, which for me, that's my big thing on BIM, but there are some differences between people's thinking on BIM. And then that'll roll into how we set our expectations, how we assemble our team, and ultimately what our strategy will be. Up here I have 3 definitions of BIM, and I'm sure there's many more. I'm not going to read them, but I do want to point out the highlighted text. The first one is from ASHRAE. Collection of interrelated computable information. Second, from Autodesk. Generate and exchange information. And third, from Wikipedia, all-knowing Wikipedia, anticipated by proponents that BIM can be utilized to bridge the information loss associated with handling a project from design team to construction team to building operator. I chose to put these 3 on here and highlight them because to an engineer, information is a big deal. When I looked at our BIM platform, what we wanted to do, I looked at information, how to, the thing goes, leverage the information. Certainly want to do that. And that was my biggest push for it. So that may or may not be your biggest thing. Maybe you're looking more for spatial allocation. So you need to think about what your strategy is based on what your expectations are once again. So if you're planning on using Revit MEP for offices that are projects that are banged out really quick, or you're looking more to look hospitals or research labs, that's going to set your expectations and thus set your strategy how you're going to use Revit. We'll go through some examples later in the presentation how we're using it. What about 3D drafting for spatial coordination? Of course you want that, but maybe that's your only goal. So you need to think about that to set your strategy. Do you want to merge engineering tasks with the model? As an engineer, yes, I do want that. And we go on down the list. Do I want to do load calculations by extracting or harvesting that information from the architect's model? Probably. All these questions that you have, you need to think about to set your strategy. You may want to do everything all at one time, and that's probably not the best idea. That way, you've got to set this plan I talked about early on in place so you can methodically walk through it. Be flexible, because as you work through it, you'll hit some roadblocks and bumps in the road, and you'll adjust your strategy and thus your expectations as well, because they go hand in hand. It's very important, I think, to have a team assembled that is going to help drive BIM forward in your organization. These people who are part of this team should not just be limited to someone like Brett here, who's our BIM manager. You need to have people who are involved with projects, who know the business. You don't want to take someone who's just really good at Revit and throw them on your implementation team just because they're really good at Revit. You need people who know your business. Let me give you an example how we did it. We took a person from each discipline, electrical, mechanical, structural engineering, architect, which was Sean. He also represented design. We pulled together a team. We evaluated the different platforms that were available out there. We talked to each other about what our goals were. What did we want to do with BIM? Those questions I asked a minute ago, we asked a lot of those questions of each other. We defined our goals, and ultimately what we did, we took that out and tested that on a pilot project. And the same people who were part of that team worked on that pilot project. And it wasn't a pretend project. You think you always want to test something out, be real secure and safe. You don't want to do that with BIM. You want to try it on a project, see if it works for you. That strategy that you were working with, you want to test it out. And then if it doesn't, then you can adjust your strategy, and thus your expectations may change. So that's what we did, and we tested it out on our healthcare projects. We figured we do a lot of healthcare design at our office. It's not the easiest type of thing to document. There's a lot of systems. There's a lot of coordination needs to take place. So we wanted to test on a tough project instead of an easy project. Granted, 2.5 to 3 years ago, it was Revit Systems 1, shortly thereafter Revit Systems 2, and now today to 2009. So we knew we had a learning curve. And I will tell you that as being a member of that implementation team, I didn't want Revit. I wanted AutoCAD MEP. We had come over from the Bentley realm, and so we didn't really know what was out there on the Autodesk world. And when I saw AutoCAD MEP, I was like, wow, this is really great. It's a pretty mature product, especially when you compare it to looking at the Revit product at that time. But our company, and it was important, we all wanted to be on the same platform so we could exchange that I in BIM. So we said we would take our lumps and move forward with Revit, and that's what we did. And we're happy we did that. I want to talk a little bit about what we used for a strategy, especially on those first couple projects. We knew that Revit was weak in plumbing and piping. So from a mechanical standpoint, we identified a strategy that we were going to draw or model the ductwork in Revit, but use AutoCAD for details for the plumbing and for even the hydronic piping at the time. That way, we were working with the strong point that the Revit offered. Our other teams, such as our electrical team, had a little bit of a different strategy. And that's going back to the team, was great where we had all the disciplines together. Each player had a separate goals in mind. The electrical team, getting back to that, their strategy was spatial allocation, elevation allocation, lighting allocation in the ceiling. They didn't necessarily show conduit. Even today I know we have to fake conduit. So, and the architects, because that was a much more mature product, they had even more grand goals in mind of doing everything possible in that pilot project. So we set a strategy, and I suggest you think about how you're going to use it as well. It has worked out pretty good. I will say this, that the ductwork models that we put out, the design we did with the ductwork, it went out to bid, and it's being built, it's almost done being built from our pilot project. We had very little RFIs in the ductwork, very little. But on the plumbing side, we had about the usual amount of plumbing RFIs. So it's a testament to that BIM does work from a 3D spatial allocation. What about multiple versus one model? We tried one model early on with that first pilot project, and it didn't really work well. We had work sharing issues, the performance issues. So we made a decision that we were going to separate out to separate models, and that's how we are today. The mechanical guy's got his model, electrical's got their model, and architects has their model, and so forth. The question is, do we have linked models? Yes, we do have linked models. That's our operating procedure right now. Yes. We have not gone back and tried it the other way since then. Is that what you're going to answer? He's asking if we break it down even further, be under mechanical and the fire protection and plumbing, piping. I imagine we would, but today, honestly, we are doing ductwork in Revit. We are doing plumbing in AutoCAD. We are moving into Revit more and more, but our strategy is still such that it was at the beginning. Okay, the second part of the setup is setup essentials. I want to hit on some things that you're going to want to think about. Even if you are already in Revit and you're working there, you may want to benchmark against some of these things to think about the way we were talking about best practices for setting up your template and other settings up front. So on the hardware side, Autodesk has a paper that talks about optimizing Revit experience. That's the words they use. And they have minimum requirements and they have minimum recommendations. In the paper, there's a website that you can go and get this actual document that has this information on it. And in there, it talks about the amount of RAM and the performance of the processor. Definitely stay to the right as much as possible. Go beyond that if possible. As you may know, Revit is a very heavy user of memory. And so the more you can have on there, the better it helps. Templates are a powerful tool that should be really looked at hard up front in your project setup. If you've been using Revit for a while and you have not really spent a lot of time at your templates, you ought to go back and look at it. I know I've been hearing that in other MEP classes I've attended myself this week, especially when I attended today. They're going to give you a template for no charge that's got all the mechanical, electrical stuff in there. And I think that's going to be up on the AU website. But templates are very powerful because it gives a project a head start. It gives a project the same look and feel. It even allows for some tasks to be done more efficiently. And it helps you set some standard processes within your organization. We have separate templates for mechanical and electrical. That way, it seems like it's a nice move from traditional CAD to BIM. The traditional boundaries are respected. There's not the work sharing between a mechanical guy inadvertently doing something to the electrical design and vice versa. File size is going to be smaller. It just seems like it's the best workflow we have today. So what does belong in the template? And this is by no means all-encompassing what you can put in a template. This is just what we're suggesting that we have done right now. We've put things in there like your commonly used families. If I can go back to my strategy on the mechanical side, on what we were doing. We were doing ductwork. So early on, we identified every piece of the ductwork system, the air handling unit, the fan, the ducts, the fittings, the dampers, the VAV boxes, the air terminals. So we wanted to make sure we had families for all that, and we put all that into the template. So the engineer doesn't have to go back out to an external file to bring in and load the libraries in. It's there for him. Things like maybe sheet setup. You can pre-set up sheets within that template, so the mechanical engineer or electrical engineer doesn't have to think about how am I supposed to name the sheet. The corporate settings on how you name your sheets can be embedded into that template. That's a good thing to do. A generic sheet border can be in there as well, so you can show that sheet. And then when the architect does give you a sheet border, you simply swap it out with the name and it'll pop right in. So those are some of the things you want in your template. You don't want to put every single family in your template because the file will start to increase in size. And a very important point about templates is a dead copy. So you've got your Imperial Library if you're working on US, Imperial Library over here on your network somewhere, holding all your families. Now you've got the template that you're so proud of yourself, you put everything in there to help yourself, get a head start on your project. There's no wire connecting those two. So be careful and understand whatever you put in that template, if you want to make a change to it, swap out a family, you've got to make sure you change it in 2 spots. So there is some consequences that goes with the family template maintenance. Keep in mind, just like your strategy, be flexible on it, the template is going to grow over time. Just because you fix it now, that's not the way it's going to be 2 years from now. You're going to be able to put more into that template to make you more efficient. So you need to identify someone in your organization who's going to maintain that template. And once again, I believe it should be an engineer who knows your business, knows how engineers think. It can maintain that template and be the gatekeeper for it. Another thing you want to do up front is to organize your project browser. Traditionally, we have folders that have all of our sheets, all of our model or base files in there. With Revit, it's all, of course, in one model now. So you're going to want to make sure you optimize an organization for those views. I like to say Revit's all about the views. You show it once, you can represent it so many different times to be more efficient. So don't just use what's out of the box. Take the time to expand on that. And this is just an example that we have here. And I want to point out that we've got two main categories, working and documentation views. And I believe Autodesk recommends this as a best practice as well. To have working views where you do all your heavy lifting, your modeling in there. You have it in wireframe mode, so you can move around a little faster. And you have things turned on that you may not necessarily want to print on your sheets. Then you have your documentation or printing views that are pre-set up. And the only thing you're going to do in there is your annotation and tagging. Nobody should really be touching those otherwise. And that will be set to hidden line mode. That's just going to help your performance when you're modeling. View templates are another powerful thing that you can do to give uniformity to your project. If you've got a building that's going to be split up into 4 areas, A, B, C, and D, and you're going to have to represent HVAC plan for area A, B, C, and D, well, with view templates, you get the view set exactly how you want in area A, and you make a view template out of that view and apply it to B, C, and D. That way those all look the same. That's just a very obvious best practice thing to do. You can populate this with as many view templates as you want. You should put that right in your template. Another thing you can put in your template, I call this passively setting your standards in your company for duct, pipe, and electrical wiring. There's nothing really, I have not shown any customization of this, but just merely as an example to show the options available in here. For those of you who have used Revit, so pretty familiar with 09 with the pipe sizes in here. But what this does give you a chance to do is to, when somebody has a pipe they're putting on the drawing, you can limit it to what pipe size you want, or also for the ductwork, you can take duct sizes out that may not be applicable. For example, in here there's going to be show 5-inch piping. We all know 5-inch piping is never available, but they do make it somewhere. So you can take it off the list. You can also set the material and thus further on. My company has not utilized this yet. I mentioned what our strategy is today with ductwork. I just wanted to show this. This is something you can set in your template. Similarly for the ductwork, here we do use this, and we have set, for example, like the flex duct length, about 5 feet, so we can control how much flex duct the contractor is allowed to use. and also for the type of fittings that we want to use for supply air, return air, exhaust, and any other air system we have for round and rectangular duct. There's also the sizing table in here I alluded to earlier, where I'm going to take out all the odd sizes, because in traditional HVAC we don't have 11 by 13 duct typically, 10 by 12, 10 by 14. Well, Revit gives you all those sizes available up front, so you can take them out to minimize what the options are. On the wiring side, we do not use this. However, there are other options you could set here to set some of your standards. I'm just pointing that out. Work sharing. This is the last subject of the setup essentials. I didn't really talk about central models yet. Our company is pretty much standardized on central models. We typically do large projects where we have to have multiple people inside the model. So we're going to want to set up a central model by invoking the work sets. So what does that mean? Why am I mentioning that? Well, you're going to want to logically break that project up. And let me show you how we've done that. For the mechanical template, not template, but when we have a project for mechanical, once we invoke work sets, we usually create these list of work sets here that may have a little bit different names in the actual project, but we've got shared levels and grids. We want to separate that off in its own work set. The Revit links, AutoCAD links, we want those on the separate work sets so something doesn't inadvertently get turned off. If it goes on HVAC work set, then somebody turns off HVAC work set for some reason, the links would go away. So you got to have a separate work set for that. Duct layouts and duct risers. Revit MEP has systems which butt heads with work sets, as most of us who have worked with Revit MEP may know that. What we have done to try to get around some of that, we've created a separate work set for risers and a separate work set for third floor ductwork, second floor ductwork, first floor ductwork. If that riser's on a separate work set, we tend to have less work sharing issues when someone, say we got an air handler that serves all 3 floors. Someone's working on the third floor duct system. If someone else is working on the first floor duct system and they're trying to connect all on the same system, we have less propensity for work sharing. If we put that duct riser on one of the other work sets, which work set do you put it on? Third floor, first floor? It's a riser. It goes up multiple floors. So that's why we've done that. And when we do get into heavy piping and plumbing, we'll also segregate that similarly by floors. On the electrical side, as you can see up here, it's very similar. It's a parallel thought process for that. We do have a separate work set right now for conduit. I believe that is because conduit's not available from Revit right now, so we want to segregate that out. Okay, one more topic regarding upfront planning. We're all part of a team here when we talk about project team. We need to talk up front with the architect. Just like when we talk about setting up our template right, we need to have negotiations, if you will, with the architect to find out what we need from them and what they need from us. We need a lot from them when we're working on the models. So let's talk about on-site and off-site architects. We have a habit sometimes of maybe thinking that we're a little more important than the other guys. But, in reality, we're all after the same goal. We want a good project. We want profitability. We want repeat customers. So we all have to work together. So just like I mentioned early on how our BIM implementation team had experts from each discipline assembled, for your projects, you're going to want to get those same type of groups together. And there may be more bubbles than what's shown up here. There's more consultants on the team. So what I'm going to do in the next couple slides, I want to go through some very specific things that, as engineers, we want from the architect. And we need to talk about it with the architect up front. So we make sure we get that, and it'll save time later on. Scope boxes. We talked about that example, how we've got an area. We want to split up into 4 quadrants. Well, the architect is going to give us those scope boxes for A, B, C, and D areas. However, what if they're doing a different scale drawing? They're doing quarter scale, but we're doing A scale. So we need to talk about that up front, saying, Mr. Architect, please give me my scope boxes for the scale I'm working on my job, not just what you need. And we can copy those out of the architect's model into our model. Another thing that we've asked the architect to do is to provide views that have ceiling heights labeled. We don't host everything to ceilings. There's some things we put elevated up, but we don't host them. So if they give us views that tell us that it's 8-foot ceiling or 10-foot ceiling, that will save us time from cutting a section and figuring out where it's at if we can just open a view up that has them labeled already. When you're working in a hybrid project situation like we are, where we're using AutoCAD for plumbing, we need export views from the architect's model. So you need to talk about that up front. Okay, Mr. Architect, I need to get an export view. I need it on this kind of a frequency, and these are the type of things I want to see in there. So that's one of the things you're going to talk about up front. And the naming should be consistent, because you're going to be swapping out that export periodically, and you don't want them to change the name on the fly, because that was just going to cause problems. And as a best practice, we've seen the other way. I don't like phasing. I don't like design options. Maybe others don't too. Keep phasing simple. Talk to the architect about not creating lots and lots of phases if they don't need to. There are times where they're going to need to create the phases for the project needs. But if they can keep it to existing and new construction, that makes it all the more similar or simpler. And when they do have to have more than existing and new, have them, when you map your phases, name yours exactly as the architect's to avoid confusion. Coordination views are another thing that we can share information with the architect. Let me give you an example with that, what I mean by that. If the architect has the planners also in their model, and there's a piece of equipment that requires a certain utility, the architect can annotate notes in there telling me, hey, this bench needs certain type of utilities, or this area needs to be exhausted because of the type of function that's going on in the room. That's another good way to communicate information across the models and not being in the same model. Moving walls is better than deleting walls. Our electrical engineering department does a lot of hosting to do spatial allocation on the walls. And if the architect deletes the wall, that element becomes non-associated and causes us problems. So if they could move that wall or move the ceiling rather than delete it, that's great. So talk to the architect up front about that. Save you trouble later. There's some additional items that we want to tell you as best practices to keep in mind when the architect is working off-site. Identify a keeper of that model. You're going to receive that architect's model off an FTP site or from hard copy on a disk or something, and somebody's going to have to put that up on your network. Identify somebody to be that keeper. Develop a frequency when you're going to receive those updates. That keeper who's going to receive them, he's going to know when the updates are coming. If there's cleanup required, he can do that as well. He can be the organizer of that. Just like we talked about in the previous slide, talk about the architect what you want in there. You may be able to negotiate work set structures that help turn a lot of things off you don't want. That way, maybe you can receive the model and just turn off those work sets, and then you'll see what you need rather than getting everything on what the architect's work set structure is normally on. If there's stuff that can be purged out before they give it to you, that'd be even better. I wanted to share with you what our best practices is for linking the architect's model. I can't pretend to know how we got to this point, but this seems to be the most stable way that we link the model. Linking origin to origin first, acquiring the coordinates, then dismissing the link, relinking with shared coordinates, then pin it. And then we go on to copy the levels, make views, make spaces, etc., and map the phases. That concludes the first part of the presentation where we talked a lot about best practices for setup. I'll pause just for a moment here if there are any questions regarding that. If not, if you think of them later, we'll talk later too.
This is actually very interesting for me because it's the first session, of course, be the last full day. It's the first session I've been to where somebody's actually talking about how we're doing stuff and you're a firm principal. And the engineer on the project, everybody seems to be either a designer or kind of down with the totem pole. And one of the things that I'm struggling with is, we have a culture where we have the principals don't even, what is that? So I'm very curious to what your involvement is in Revit day to day. Are you in the model, or how does that work? I mean, I'm trying to figure out that, they sort of buy into it, but they're not as involved with it anywhere what I imagine you.
I'll take a minute to give you a history on that. The upper management, the COO, identified a person from each discipline early on, probably 4 years ago, to map our BIM roadmap. So we came together, myself, Sean, there was a structural engineer, and the three of us kind of created a roadmap where we wanted to go with CAD/BIM. And yes, I'm still involved. I don't do duct layouts every day, but I open the model up, I make changes. I tell the other guys sometimes, hey, you're not capping the ducts, or you're not making systems. That type of involvement, I'm on it, yes. and I'm on the BIM standards team at my office as well. Somebody else have a question? Yes, sir. Okay, this gentleman's asking, how do we control ceiling items like lights and diffusers? The engineer who knows what they're doing puts that in the model, puts it in their model, and the architect can show it if they want to. Okay, I'll take one more question. You had your hand up, sir?
Well, my question is about this hybrid projects. I've been evaluating Revit MEP to implement into our company, and the upper management seems to think that we're just going to, do away with AutoCAD and switch to Revit. And it's just not that simple. It just simply doesn't work. And you've already said you don't use it for piping.
And we will be. We're moving into that now with 2009. It's stronger. And I know that there's another content drop recently. I think it's available now. We will be moving in that realm, though.
It's, at the moment, it's found pretty hard to do sewer piping with it. But, just the actual nuts and bolts of implementing this, do you draw the piping in AutoCAD and then, import it to, how do you get it on the sheet?
Yeah, that's a good question. Okay, Rain, let me address that. He's asking how do you get the piping and plumbing on the sheet. Well, right now our delivery method is we have separate sheets for AutoCAD. We tried it the other way, where we just basically had a model or base file for the AutoCAD plumbing, and we brought that into the Revit environment. We brought it in as an import, and it slowed it down a lot. And we actually cut the model in half. We had a ductwork model for the pilot project, then we had a plumbing piping model, which was basically just Revit views with imports inside of it. That's how we did the pilot project. We're not working that way today. That was a lesson learned. We said we're going to keep them separate right now. When we're ready to do Revit, MEP, or piping and plumbing, we'll do it. Sean, could you answer that? This is Sean, of course, again.
The question was, why does this process work better than any other process, or why do you have to detach and then relink it? When you do the initial origin-to-origin link, first of all, you have to do origin-to-origin. You can't do center-to-center, right? Because one thing that I guess was kind of missed is our templates are all perfectly aligned origin-to-origin, right? Because we went in and we identified origin because we linked in the AutoCAD file to identify origin and set origins based off that. So you initially bring it in origin-to-origin. You acquire the coordinates, and then when you detach, because you don't try to simply reset it to look at your shared coordinate system, because it doesn't always like to shift. It might try to shift on you. Okay, we've had difficulty with that. So just get rid of it. It's virtually an empty file anyway, so there's no problem to doing it. Just relink it and use shared coordinates. And then from there on, it will respond accordingly throughout the entire project. Now, with that being said, you're linking in. Now, and there's a lot of people that do different things, right? We are linking in the central file. So on the network system, we have subdirectories, electrical, architectural, structural, so on. We have central files that we link directly to. However, our Windows user profile is set up so that I can only read from mechanical, electrical, structural, and I can't write to it. As soon as you have somebody that can write to both of them, in 2009, Revit will start checking out work sets in the linked central models. Does that make any sense to anybody? And then it will not recheck them back in. Okay? It'll recheck in the work sets that are in your model. But so if you're electrical and you're linking my model in from central, and you have the ability to write to the architectural folder and the electrical folder, you went and selected an object through the tab process and hid an object, okay? You would then actually go into my file and check out that work set with your username, even though you've never accessed my file. And that work set would be locked with your username. You saved essential, you would check everything back in, and we have to go back and reset up the files. So that, right. And now what, Autodesk says that's impossible, but they've also said that their methodology is for you to move and create a local version of the central models each time, and if you get to the size of the files that we get to, that's just obscene. so we don't go that route. We have made sure that our Windows groups are set up the way they are. We're around, let's see, we range about 200 megs. We try to keep them limited down to 220,000 square foot per floor plate, at a hospital level. Okay, but we also don't model every nook and cranny either, right? We don't do the model for the base. That's if we show that, we show an elevation, we put a drafting line on it.
Let me respectfully ask you to turn that mic, get back to presentation.
Yeah.
Thank you. We'll be available as long as you guys want for questions afterwards. Thanks, Sean. Okay, let's go to the second half here. It's some nuts and bolts and some examples of the benefits that we have seen. Okay, I want to talk about families and best practices for families for MEP. Let me categorize families in a couple different categories. Generic families, out of the box or default families, customized, and vendor families. We're going to touch on those things and also on catalogs a little bit. As part of your strategy, going back to the beginning of the presentation, think about how you want to represent your families. You don't want to necessarily model every little thing, and you probably have heard that in other presentations this week. I know I have. Keep it simple to what you actually need out of that family. This is just a simple box that has instance parameters for the width, length, and height. This can represent any kind of piece of mechanical equipment. You can slap a connector on it if you need to connect pipe or duct to it, and then you could add some engineering data if you need to. But this is one thing, and it gives you one generic mechanical equipment family or electrical family that you'd have to maintain. That's one strategy you could use. If you want to look at out of the box, how can we leverage the out-of-the-box families that are there already? Up here is the out-of-the-box utility set. What we did for one of our projects, we basically re-engineered it, is one way people say. We looked at how it was built, switched it around a little bit, and went to a top discharge instead of horizontal, resized the discharge, resized the inlet, and it was project specific without a lot of effort. Those are the type of things you want to look at, save time. Another example, this air-cooled chiller with 6 fans. We only needed 4 fan units, so we were able to crunch that down to a more project-specific item. We didn't have to redraw all these fancy graphics. We could have put a box in there with a connector. This was available, and it was fairly easy to change it, so we did. Early on, when we had our strategy of just doing ductwork in Revit, and I talked about all the components we had to build families or use families out of the box, VAV boxes is one thing I looked at right away. We customized our VAV box so we could pick up the flow, bring the flow through, and how we did that, or how we did our customized box, we created types for each size of an inlet. Your typical Titus or Price, Tuttle Bailey, they're all pretty much the same. They have 4-inch inlet through 16-inch inlet here. We created one family with a coil, one family without a coil for the single inlet box. And that way we were able to populate it with any kind of instance data that we needed for a schedule, such as GPM on the water flow for the coil, what system it was, pressure drop, and so forth. This was our first generation of our family. This box you see out here, grab my pointer. This box out here is basically a clash detection for the control box. We can modify that 18 inches, 3 foot, whatever we need to make sure that space is respected in the model. That was our first generation. It took a while to get there with Revit systems. Today, we've got a little bit more intelligent box that we're using. And I just wanted to show this as an example of what you can do to save time in your model. This box right here has a lookup table. It looks up based on what the connector is seeing. It will flex that physical box. It will flex that inlet. It will flex that outlet to be a project-specific instance because it knows what's connected downstream of it to the air terminals. If later on we come back and change the CFM that's downstream in this box, the box will update, but right now the ductwork still stays the same, so we have to go back and change the ductwork. But it's still a nice progression into getting better at what we're doing with Revit MEP, customized family. Catalogs is another strategy that you can use. One of the presentations I heard earlier this week was they told me if you got more than 5 or 6 types, make a catalog instead of creating types. That way you can populate your model with only what you need. For example, this slot diffuser is FL10, FL20, and so forth. If you only need the FL10, you bring that family in, you only have to bring in this piece of the catalog. And it's managed externally in a pretty much a friendly file here in Notepad, so you can add more to this very easily. I want to point out one more thing as a best practice on this slide here. This word corp. What we have done as a company, if we customize something, create something, and set it as a standard, which is a pretty loose word sometimes, but we put corp in front of it. That way we know that we created that. It wasn't something that came out of the box. That wasn't something that somebody else emailed us and we got thrown in the project. So that is our best practice, how we keep track of what we make. The vendors are starting to come up to the plate. I got 3 slides here of 3 different manufacturers of rooftop units. Manufacturers A, B, and C. And in your handout, it lists who they are and their websites with how they are proclaiming they've got Revit stuff. But what I want to point out is, traditionally, it's great when we can get this from the vendor. So we can do that spatial coordination for the mechanical equipment. But now, look, we're getting all giddy because we get engineering information. And that is good, but you got to take a grain of salt, you got to take this with. There's not necessarily going to be right now a uniformity between what this is. Let me show an example here. This for type A here, we've got supply CFM, power exhaust, external static pressure, and so forth under the category mechanical. The second vendor is a little different. Although the graphics look very similar, their category mechanical's got different stuff here. And manufacturer C has even different stuff under the category mechanical, yet the box kind of looks similar. You know, that's okay because I think this is a great step in the right direction. We can get the graphics, we can play with this and put our own parameters in there, or maybe we want to relook at parameters we have. I know Autodesk has some beta information they're looking at along with vendors on this, on basically looking at the different parameters that should be standardized for mechanical, electrical, and probably all types of equipment. Autodesk Seek you can go to, and you'll be able to find who has Revit content today for mechanical and electrical. I think there's a couple other families listed inside of your handout. 2 more sections in our presentation today. I want to show you some real examples of benefits that we have received with Revit MEP. We're going to talk about interference checking, scheduling, data evaluations, coordination, and so forth here. Let's jump right into interference checking. I already gave away the punchline to this one when I said we did the pilot project. We were able to have very little RFIs regarding duct fit on the project. This was a 140,000 square foot ambulatory care center. It was very intense on the load side. That was the first pilot project. Another one piggybacked right on it. There was a 250,000 square foot emergency room and critical care tower addition to the hospital. Both projects we modeled with Revit MEP, and we had very little problems with ducts fitting. Revit has the built-in interference checker. Navisworks is something else we use. Navisworks has more capabilities. However, it's a dead copy. Revit is about as live as you can get. As soon as someone rides it up or drives it up to the central, that's what information you can interference check very quickly against instead of pushing it out to external Navisworks file. I'm really big on schedules. I think this is one of the big things that engineers can get out of this. Way back beginning of his presentation, I talked about the I in BIM. That's a really big deal to me as a mechanical engineer. The spatial allocation is great. It's going to save time and money later on. But be able to extract the data and use that data, manipulate it to look at things like watts per square foot for lighting. As the authority-having jurisdictions become more aware of what the energy code really requires us to do, and they're saying, show me compliance, through ComCheck or something else, we can go right back to Revit and we can say, okay, what is my watts per square foot for my different spaces? This is an equipment room, and it shows me I got 1.4 watts per square foot. We almost get this information for free. These schedules you can put in your template. The power of Revit, if you want to go to equipment room where this light fixture A3 is, you click on it and it'll show you the views where that's at if you want to change it. Or you can change it in the schedule. Similarly, for power density, you can do the same thing. You can look at the watts per square foot. You can look at the equipment that's connected up. Here you have a computer. You can go to that computer if you need to find it to make a change. That's about all I'm going to say. I'm not an electrical engineer, but we are using this for our electrical engineering department. Okay, on the mechanical side, I put together a simple schedule here of how I can leverage the data as well, with the room number and name, the supplier, CFM, and for healthcare projects, this right here is a big deal. Air changes per hour. The health department a lot of times says, give me an air balance sheet. What kind of air changes you got in there? Well, now instead of pushing that out to an external or retyping it in an external file, you can almost get it for free here. You can get CFM per square foot. You can compare supply versus return air to look at the pressure in the room. This is just showing a supply, but you could add exhaust, return air on there as well. I think this has a lot of promise, and it's here. Quantities. As engineers, at least at our firm, we're not asked to validate a cost estimate, but we may ask our opinion. You may ask, in that job, how many fixtures in there? The contractor says he's got 1,100. And you can say, oh, there's 1073 to be exact. It's nice. Same thing for receptacles. Quickly look at quantities. This is a benefit we're getting right now out of Revit MEP. This screen here is actually from Revit 2008. This is our pilot project of the ambulatory care center. And one thing I did in this project, I kind of looked at, other areas in my project that have high velocities. I need to go review the duct sizing. This is an early example of how I leveraged some schedules here by looking at all the ductwork, the CFM, the pressure drop associated with that portion of ductwork, and then the velocity. You can sort this, of course, by highest to lowest, and you can find out where that piece of ductwork that might be too high of a velocity or pressure drop. Revit has the ability to show you the loads on a panel. In talking with our electrical engineers, they don't really use this a whole lot, but it is a spot you can go to see what's hooked up on a panel. And it's built into Revit. We don't use it a whole lot right now. Data evaluations, another example. This is very similar to the example on the schedule I showed, where you can use the color fill feature to quickly look over your whole building, or at least a floor of the building at a time, or a view, because Revit's all about the views. You can show the different velocities very quickly to look at where is the velocities that are too fast, perhaps, in my drawing. Elevation coordination. Well, part of our workflow process is before we send the drawings out, we do a room-by-room coordination. And the electrical department, architectural department seems to always dominate that because they're always looking to make sure they got everything at the right elevation. Previous life, we would always put it on the architect would take it and put it on their elevation, and maybe they would label what it was, or maybe just show a box there. Well, now what we do is we can pull workstations into our meeting room, and we can live coordinate where those devices go, so we make sure they're in the right location. It's a real benefit we're getting right now. Once it's done, it's done. And our electrical team had very little RFIs on elevation of devices. This slide almost fit in back to when we were talking about families, because I want to share with you the best practices that we're using regarding families such as lighting, receptacles. Once again, this is got our naming convention I talked about earlier. We created this, so we put Corp in front of it. And this is parametric data we're leveraging here to show we've got a 277 volt light and we've got a 120 volt light if this was to be pulled down. And we can flex the dimensions of it and we can flex the load. That way, we only have this family to maintain for surface mounted lights. We don't have families for each size and the load, of course. We wouldn't do that. But we can maintain one family and just stretch it and change it on the instance parameters inside the model. And similarly for the receptacle, we have a corporate receptacle here, and we'd have duplex, single, quad. We can basically also put the elevation on there. So if the architect wants it at a certain height, comes back later on, wants to change it, we can put this in a schedule and change it all at one time and move it up. The power of that data, we're realizing that now. Revit has the virtual circuiting option too in there, where if you highlight the receptacles, you can get showing what's all related to each other. It's hard to see on the screen, but it's there, and then it also will point to the panel that it's associated with. We don't print this on our drawings, but still it's a good check to see if everything's connected up. This duct image on your right over here is an interesting one. We recently did a project for an old hospital. The hospital is probably 40 years old. I'm not sure if that's old anymore, but I'm almost 40. So But this here was a situation where we had to bring the duct from a rooftop unit, we had to drop through the floor an existing concrete structure, but we couldn't cut the joists. Like, we weren't going to spend the money on bracing the hole in the floor. So we had to straddle the concrete joist. And to show that to a contractor so he could understand what we're trying to do, this was, we put right on the deliverable, this drawing, to show we got kind of like a pair of pants fitting here as we spread the ductwork to get around those joists. Nice little thing you can do now, different ways of delivering your project. Similarly, this can go right in the drawing as well to show an electrical room where we have access space required out in front of electrical panels. It can not only go on the drawing, but it can also be used by the other trades who are in the model can see this and say, hey, I can't run anything over that. Finally, the last topic of today's presentation is talk about some helpful tips. Some of these may be repeated, but they're worth repeating. It's just the best practices thing that we have seen from lessons learned over the last couple of years, and I'm hoping that you guys will get some benefit out of reviewing these tips and possibly change your workflow. Number one is exceed the hardware recommendations if possible. Number two is a big one. Allow time for Revit research and development. You're investing your company's time on going to a new platform. Allow the people who are experts in electrical engineering and mechanical to continue that implementation by looking at how we can make our BIM better. Keep them together. Allow them time to go to the websites, to talk to other companies like us and you, and to find out what the best practices are for that day. Kick off the project team with a BIM meeting. Just like we had a BIM implementation team, have a project BIM team up front. Talk about how you're going to do things. Talk about those working with the architect items. Follow that up with a discipline-specific one. Get your mechanical team together, your electrical team together. Go through things like, how are we going to name those work sets? I didn't show you a standard name of work sets. I showed you kind of a framework for work sets. Well, dive down to details. How are we actually going to name these work sets? Talk about issues that are with the software. Autodesk publishes out what they know at the time, at least, of what's wrong with the software. Share that information so someone's not banging their head against the wall on something. Talk about staggering your save essentials. Use a workshare monitor, if you have that, to see who's saving to the essential at each time, and then wait so you can save after they're done. This is an important one. Talk about what happens if it crashes. Don't try to be a hero and say, it crashed on me, I'm going to go throw it right back up there. No, let's talk about what the process is if we do have a crash. Who's that person that's going to fix it and get the central model better? Utilize a copy down routine. Does anybody know what I'm talking about when I say copy down routine? Okay, this guy does. I want him to briefly explain it.
Okay, what Kirk's referring to with the copy down routine is there was a discussion thread in the Augie forums about a year ago. I don't know how many people here are familiar with Augie.com, but they've got great discussion forums out there where you can get a lot of information, you can get questions answered. It's basically a help group for anybody who uses Revit or any of the Autodesk products. And what it was is people were talking about trying to do a transparent local copy procedure so that they could give their users a better way to copy down the files. They don't have to copy it every morning, rename it, and then the next morning repeat the cycle. And what it also helps is it keeps you away from having stale models out there. A lot of times you can have a stale model. Somebody hasn't worked on a project for a week, and something has happened where the central models had to be reestablished. Their model is no longer linked to central once there's a new central established. If that happens, somebody could work all day in their model and go to save the central at the end of the day, and they are not going to be able to save that data out. And what it is this is a routine that was posted by a couple of Augie members who kind of went back and forth trying to almost outdo each other with how simple they could make it for the end users. And what it does is we put a shortcut on our desktop now that copies down a new Revit local file for them every morning. It renames it appropriately per our corporate standard for the local files. Then it opens the proper flavor of Revit, whether it's architecture, MEP, or structural. And that way the person only opens it with the right version of Revit and with the right year version of Revit. That kind of keeps us away from having any accidental upgrades, which I don't know how many people here have ever had an accidental upgrade and how painful that can be. And we kind of made it as flexible as we could for our users. We put it out there first. I asked for feedback as to what they wanted to see in it, and now that routine lets them open a file in a multitude of different ways. They can open detach from central, with all work sets available. They can specify a work set on a heavier model, so they're only opening one work set or two instead of the entire model. They can, even our electrical folks, we put in a little button there, they could open their electrical model with Revit architecture. Because of the calculations that happen in the background, a lot of the things they do function better in Revit architecture. They can place receptacles quicker and faster, and they can do a number of different things easier. But that's what he was referring to with that. It's really simplified things for our users, and it's really helped us with any crashes that we were having in the past because of models getting out of sync.
Thanks, Brett. And that's available at augie.com?
Yes.
We didn't really talk about shared parameters too much, but just maintain one for your company, your organization. I did touch on that with the vendors, that we may have to reset what you want to do with your shared parameters based on how they're responding to the market. Keep that committee together to funnel the improvement ideas through. Email's great, instant messaging better. We utilize instant messaging on projects, so we can send somebody something and say, hey, you know, get out of that. I need that part in the model. Relinquish it. Model in wireframe mode, that goes back to the working documents, working views instead of documenting views. And on the electrical side, we have made a strategic decision right now to limit our connectivity to 277 volts. We are not connecting up to the 480 volt mechanical equipment right now. We're in separate models anyhow, but we're only up to 277 for lighting right now. And view templates, those are very powerful as well. Rely on those. Customize your project browser. Compact when saving, but be careful about purging. We have found, as a lesson learned, that if you purge out all your unused families or types, you come back, you want something back, it's hard to get back the family you purged. It's difficult to get it back in there. Avoid design options. Definitely avoid that. Revit MEP does not work well with design options. If you're in a situation where you have to, if the architect or designer is using design options, just talk to them, try to get them out of it as soon as possible. Hold off on setting your model up if possible. Revit MEP does not work well with design options. Utilize clipboard for copying views, from copying items out of one view to another. And I also mentioned about putting the links on a separate work set as a best practice. Keep Autodesk or AutoCAD line work out of your model. Another great thing that we've done is set up your space tag. In 09, we got spaces, we can't copy the rooms anymore. There was that little bug in the beginning where you can't get the room name and number to come across. Well, there is a utility now that you can pick that up. Get the space tag to read the room name and number. So set that up in your template. Create the work sets. Make sure the visible in all views is checked. So if you're in a view and you create a work set and you uncheck that box, guess what? Somebody else is not going to be able to see that item on that work set unless they're in that view. Use an origin marker and place it in your model. So that way, if you are a hybrid project, you can align things. Scope boxes are a definite plus. You got to use those so your views look the same, your sheets look the same as the other disciplines. And we utilize dependent views quite a bit. Cut down on our work. Another nice little tip you may or may not be doing is using a drafting view. When you're ready to close out your Revit project for the day, you're saving back to Central, and close it out. Close all hidden windows, go to a drafting view, and then save from there. That way, the next time somebody loads up the Revit model, it's going to come quicker. It doesn't have to regenerate all those other. If you close it out in a heavy view, it's got to regenerate all that line work in the background. If you're in a drafting view, it's only got to generate the annotation or whatever you call that drafting view. Brett alluded to this earlier. Consider placing devices in a Revit architecture. Our electrical department has done this, and it's very successful. They've probably been doing it for about a year now. Whereas to place their lights and their things that are hosting to the walls, they'll take the electrical model, because it's still their model, but they'll open it with Revit architecture. We have the benefit from being a full-service firm that we have both Revit architecture and Revit MEP available to our users, so they can open it up in Revit architecture, which moves faster. It doesn't have the calculations going on in the background, so they can quickly place their devices. Then they want to do their other work, they can go back into the electrical model and do their work there. Lean on, I talked about conduit. We're using duct right now. I know a lot of you have been using pipe. I think that's okay too, because you're really just going for the spatial allocation. Lean on schedules. I think there's a lot of promise of schedules. As a backup plan, print your sheets prior to your deadline. Don't wait till the last day to print those sheets out, because that will give you an opportunity to go back and apply the view templates so you get the output that you desire. Bottom line is accept what the software can do for you. Don't force it to do something it's not really unable to do. Grow with it. We went through a lot of different information here in this presentation. We talked about really starting right from the start by setting your expectations to develop your strategy. Looking at our setup essentials, working with architects, all that upfront information will save you time later on. Revit is really skyrocketing up, in my opinion, for engineers, and the more information you put in there, the more upfront planning, you'll be that much more ahead of the curve when it comes up to speed, and plumbing and piping are much more robust with it. So I hope today that I was able to give you an engineer's perspective from right in the beginning to where we're at today. I will take all questions. I'll try to answer them. If I can't answer them, I will definitely take your contact information, or you can drop me a note and I will get you the appropriate answer. As I mentioned before, I have Brett and Sean up here. If there's anything that is pertaining to platform, Brett's going to try to help me with that question. Architecture, Sean can help me with that. So I'll start with questions. Yes, sir. Okay, the question is, explain a little more about our custom VAV box family. We have a lookup table that, based on the flow that's connected to that box, the size will change based on that. So in the lookup table, we have values for the airflow, and those values will be associated with the inlet size, the outlet size, the physical size of the box. Yes, sir. The question was, have we given a Revit model to contractors? The answer is no. I am actually a little bit against it. I'm going to be weak here and be on the fence. I don't know how the market's going to merge on that one. We put a lot of time into customizing some of our families, like the one the gentleman just asked about, the VAV box. And we don't just want to give that technology away. We're willing, just like today, I'm willing to share to help you guys. But give it to contract, I don't know yet. Okay. Yes, sir. Okay. 2 questions. One was the time it takes. Is there additional or less time? It takes more time right now. It just does. Well, on the pilot project, it took probably 25% longer, but the subsequent projects, it's probably closer to 10 to 15%. Okay. We are getting the data out of it now, which we didn't get before. The other question you had, sir, was about turning vanes and duct insulation. We don't show either of those. We allow our specifications to tell them where they need to do that. We do not show it in the model. Any more questions? Okay. The question was, for our pilot project, what kind of training did we have and what are we doing now? We had a training from a reseller because none of us knew anything about Revit at first. We had very basic training, which was very basic because there was no manual out there at Revit Systems 1. There was hot and cold feelings from our engineers on it. Some liked it. Some thought it was a waste of time. They could just go through do the tutorials themselves. If you were a strong CAD user, you probably leaned toward that edge. If you were not as a strong CAD user, you kind of liked the basic training. Then we had a lot of over-the-shoulder training since then from a reseller, and then now we have experts developed in our office who really, really are good at Revit, and they train basically with their mentoring process the next people. Each department has done it a little differently. Architectural department, I know they have lunch and learns. Mechanically, we have not done that yet. We've just been doing mentoring over the shoulder at this point. It's a double-edged sword. The question is, when do we get involved in the model? It's a double-edged sword because as an AE firm, one of our benefits we offer our customers is that engineers are on board right away. We have that available to you, Mr. Customer. Your engineer will understand the process of the project, what the goals are right from the start. So we are on board right away. The model is usually created once a floor plate is available, and we try to populate it with the data, and we try to use the data out of there, creating our spaces and create a load map, basically. We're still using Trace, and there's some redundancy with Trace. So early on. Yes? How much time, question is, how much time coming up to a deadline do we set up for clash detection, and when do we do it? Okay, let's see here. That's a tough question. We don't have a standard procedure in place right now. I mentioned how we do a room by room at the end. That's the most appropriate time to go ahead and run those clash reports. We have not, as a firm, decided who's going to take responsibility for that. It seems that our project architect, it should fall to, because we're a full service firm, we have not formalized that procedure yet.
Actually, in our firm, the project architect leads the entire process. Prior to any laying out of any ductwork, we do what's called a spatial allocation, which is we sit down with all the engineers and architects in a room, and we cut sections through the model. We save the views of those sections, and identify with reference planes where each person gets in that ceiling sandwich. Follow? Okay. From there, we look at areas that are tight on a project. We know where our problems might be. And then from, like, once you get in more into the DD level, you got to come back and check it. And you go back to that view and you check it. And then at, like, say 3 weeks out, you might run an interference check, but you run it out of the mechanical model because everything interferes with mechanical, right? So, and our belief is you don't go to Navisworks unless you absolutely have to. In fact, what we did on that pilot project, we had the sprinkler contract submit shop drawings to us. We put the mains in a separate model so that we could clash, if you will, against those. Pneumatic tube, things of that nature. And, you know, that's just easy stuff to toss in, right? So at that point in time, we run all the collision reports out of the mechanical model for each system, and you figure out exactly what's going on with the model at that given time. But for the most part, you've been designing in 3D, and so you kind of know what's going on. Another thing I would recommend is doing walkthroughs. Run a walkthrough through your building at an architectural standpoint, because you kind of get an idea of really what's going on, because you might actually have outlets that are a little higher than you originally thought, and when you walk through at the proper height, you get a sense for that.
Any other questions? The question is, the other discipline, do we have those linked into each other's model? The answer is yes. Whatever Revit models we have available, whether it's structure, architectural, electrical, we would have it linked in, and if we need it in that view, we would have it turned on and use it for coordination in those working views. They would be all loaded. Well, the structural, it depends what we're doing in the view. But yes, it would be available. At this point, I'm going to conclude the presentation, but I will stay here as long as it takes to answer your questions. Thank you. Please fill out the survey.